In this video, we're going to examine a process called factoring trinomials that we'll see can be very useful to us as we learn to solve quadratic equations. We're going to want to get really good at this technique because we'll see that trinomials appear throughout algebra and through calculus. When we're able to factor them, we'll know things about their zeros and something about their structure for graphing them. We'll also see that we can use the same strategy for any quadratic trinomial that actually has factors. In order to apply a strategy to trinomials, first we need to know what they are. So a quadratic trinomial is going to be an expression of the form a times x squared plus bx plus c, where a, b, and c are real numbers. Our strategy is going to involve looking for factors of a times c that add up to b. Once we found those, we're going to use something called the asterisk method. This may be a little bit different than methods you've seen before, but I find it to be particularly useful and simple when factoring trinomials. Let's take a look at a few examples in order to master this method. All right, we'll start with an example, x squared plus 7x plus 10, and we want to factor this. So in other words, we want to find two simpler expressions that multiply to be x squared plus 7x plus 10. So we're going to look at, so here we can see that a is equal to 1, b is equal to 7, and c is equal to 10. So our strategy is we're going to multiply a times c, that's 10, and we're looking for numbers that multiply to be 10 but add up to be 7. So the factors of 10 are either 1 and 10 or 2 and 5. And we can see that it's this pair that add up to be 7. So those are the numbers we want. We're going to use what I call the asterisk method. So we're going to draw ourselves a little asterisk here. And we're going to put a times c up here and b down here. So we're going to write our 10 here and our 7 down here. Now we just discovered that the two numbers we want are 2 and 5. So I'm going to write those two numbers here and here. I'm then going to take my a term and I'm going to write it, I'm going to take this first term and I'm going to write it in the two remaining spots, but I'm going to write it without the squared. So I'm going to write 1x and 1x. I don't even need the 1, but I do need the x, but without the squared. And the reason why is if we look at this, the two sides, we can see we've formed what look like fractions. They're not fractions really, but they kind of look like it. And so what we're going to do is we're going to simplify those if we can. Now in this case, we can't. 1 and 2 have nothing in common other than 1, and 1 and 5 have nothing in common. But if we could simplify them, we would. And what happens then is that these become our factors. So we have an x and a 2. So our first factor is x and positive 2. And then we have an x and a 5. So our second factor is x plus 5. And so what we found is that those are our two factors. That is exactly equal to x squared plus 7x plus 10. And so we are done factoring. All right, we'll try another one. We have 6x squared plus 11x plus 3. So remembering that this is a, this is b, and this is c. We're going to draw our asterisk. Right, AC goes up here and B goes here. So A times C is going to be 18 and B is going to be 11. Now we're looking for factors of 18 that add up to 11. So the factors of 18 are 1 and 18, 2 and 9, and 3 and 6. This pair adds up to 11. So we're going to write 2 and 9 in our spots here. Now I'm going to take my first term and I'm going to rewrite it, but I'm going to drop off the square. So I'm going to write 6x on both sides. Now we're going to simplify. 6x and 2 both have a 2 in common. So I'm going to simplify them by dividing by 2 and I get 3x and 1. 6x and 9 both have a 3 in common. So I'm going to divide out that 3 and I get 2x and 3. Those form my factors. I have a 3x and a positive 1, so my first factor is 3x plus 1. My second factor is 2x plus 3. Let's check. Let's multiply that out using the distributive property. So 3x times 2x gives me 6x squared. We're off to a good start. 3x times 3 gives me 9x. 1 times 2x gives me 2x. And 1 times 3 gives me 3. And I do, in fact, get 6x squared plus 11x plus 3. And so I have factored correctly. So my final answer, again, is 3x plus 1 times 2x plus 3. All right, let's do a couple more to get some more practice. So we have 6x squared minus 11x minus 7. Again, that's A. That's B. Notice that B is negative this time, and C is also negative. A times C is going to be 42. We don't have to worry about the sign for that one, but we do want to keep in mind that B is negative 11. That's going to be important. So there's our AC and there's our B. So now we need factors of 42 that add up to negative 11. So let's make a list. Factors of 42 are going to be 1 and 42. Well, those don't add up to 11. We have 2 and 21. Those don't add up to 11. Then we have 3 and 14. Notice that if we do 14 minus 3, that's going to give us 11. Or alternately, if we do 3 minus 14, we get negative 11, which is what we want. So I did not draw my asterisk over here correctly. So we can use 3 and negative 14 as our two factors because those add up to negative 11. Now we're going to rewrite our first term without the squared, so we get 6x on both sides. And now we simplify. 6x and 3 are both divisible by 3, so we will factor that out. We get 2x and 1. 6x and negative 14 are both divisible by 2. So that gives us 3x there and negative 7 here. And those form our factors. So our factors are now 2x and positive 1 times 3x minus 7, since the 7 was negative. Let's check our work. That is 6x squared minus 14x plus 3x minus 7, which is in fact 6x squared minus 11x minus 7. And so this is our correct final answer. All right, we'll wrap up with one more just to make sure we've mastered this technique. So here we've got 5x squared, that's our A, minus 18x, we've got a negative B again, and then C is positive 9. So we've got 5 times 9. Up here is 45, and then negative 18. All right, so we're looking for factors of 45 that add up to negative 18 this time. So 45 factors, we've got 1 and 45. There's no way to get an 18 out of those two numbers. Then we've got 3 and 15. Those add up to positive 18, but if we also know that we could make negative 3 and negative 15, and those would give us a negative. When we add those together, we get a negative 18. So we can use both of those as negatives. The only other option is 5 and 9, and those add up to 14, or if we subtract them, we get 4, so those don't add up to negative 18. So our pair that we want is this negative 3 and negative 15. Now notice that we needed a positive 45. The only way to get a positive number when we multiply those two together is for them either to both be positive or both be negative. We also needed a negative 18, which means at least one of them better be negative. So we're going to have to choose the numbers negative 3 and negative 15. Once again, we'll write our 5 here. So we have 5x and 5x. On this side, there's no simplification to do. We're just there's no common factor for 5x and negative 3. Over here, they're both divisible by 5, so we get x and negative 3 when we do that, which means that our factorization is 5x minus 3 and x minus 3. Let's check our work. We get 5x squared. Then we get minus 15x minus 3x and plus 9. I'm using the distributive property there. And so that is in fact 5x squared minus 18x plus 9. And our work's checked. And so this is our final factorization. Okay, summarizing what we've learned. We saw that we have a method, the asterisk method, that we can use to factor all trinomials. They'll all follow the same logic. And that logic is that we're going to look for factors of a times c, the first and last coefficients in our trinomial, that add up to b, the middle term. However, we didn't see any examples of it here, but you are going to come across some trinomials that actually don't factor. And we'll learn some techniques later on that help us deal with trinomials that don't factor nicely for us.